No, it's sticking at 200. I think if we've taken anything away from this, it is that the carbon pile load testers are complete garbage and a huge waste of time and money. Hey folks, welcome back to the show. And for those of you that are new, my name is Luke, and today's video is going to be all about 12 volt lead acid batteries, specifically for automotive. I don't think a lot of people realize how much time mechanics and technicians spend messing around with 12 volt batteries, trying to rescue them, writing up quotes for them, trying to get them warrantied out at the dealer, which is a nightmare. The premise of the video is, I'm sure a lot of us DIYers or techs or whoever have a smart charger with a repair mode on it. Now mine is specifically has a repair mode for 12 volt lead acid batteries, not for any other type of battery. And I have a battery that's recently been tested as bad, a little bit of history on the battery. It's about 4 years old. It was in a daily driver, no sitting, extremely cold conditions like sub 20 degrees Fahrenheit. I noticed some hesitation in the cranking. So I went ahead and got a little battery tester. It tested bad. The battery's rated for about 750 cold cranking amps. Based off of the internal resistance measurements, it's estimating that it's down sub 550 cold cranking amps. I want to get a baseline series of tests. We're going to do state of charge and resting voltage. So state of charge and resting voltage are derived from the same number, but state of charge will be represented as a percentage. Then we have internal resistance and state of health. Again, based off of the same number, but state of health will be represented as a percentage. And then we have an official load test, and hopefully we can get some information out there about when it's appropriate to run in repair mode and when it's not. If this was on a daily driver, this battery was used every day and not sitting. How does the repair mode affect state of health, state of charge, and our load test? So we'll run these series of tests. We'll get a really good baseline. I've got plenty of equipment here to do some redundancies to verify some of our data. So we'll do that. We'll put it on the smart charger on repair mode. We'll let it chooch and do its thing. We'll come back in a day or two. We'll rerun all of our series of tests and see if there was any kind of improvement to see if that mode would be applicable to a battery that was utilized every day, or if it's only for a battery that possibly was sitting at a low charge for a long period of time. Let's get into testing. Okay, so we're doing state of charge with basically our resting voltage, our state of health, and our internal resistance. This is a specialty internal resistance meter that will also give us voltage. This is just a run-of-the-mill multimeter that is just for voltage. And then the Aclo battery tester is going to give us our state of health, state of charge, our internal resistance, and our resting voltage all in one package. And then we're just going to use these other tools to verify what it's saying. So let's start with this first. I have another video with this tool that I'll put down in the description. So we're going to go over to car. Regular flooded is our type of battery. Cold cranking amps is the standard that the battery is rated for. It's rated for 750 cold cranking amps, and it's gonna run a battery test. There's a couple things that we wanna look at. So it's gonna give us a lot of really good information. Our state of health is only at 53%, and that's why it's testing bad. Its estimated cold cranking amps is at 548. State of charge is really good. It's saying, hey, it's at like 12.6 volts, which is like a fully charged battery. And then down here, this is our internal resistance measurement. This is in milliohms, and only really special testers can do milliohm testing. And then we're just gonna verify with some of our other tooling that it's not lying to us. Let's verify voltage really quick with just a multimeter, 12.57. This will also read voltage and our milliohms. This one disagrees slightly. It's saying 5.25. So let's go with this one because this is a specialty tester. All right, next up, we're gonna do the load testing. I know that some of you might be thinking like, well, if you look at battery testing procedures, oftentimes they recommend turning on your headlight bulb for like 10 seconds before you run testing. I already did that before we started rolling the camera. I didn't capture it. All right, I've never had a chance to use this yet, so I'm pretty excited. This is its maiden voyage, and I tried to put you pretty straight on so that we could help reduce the parallax of the readings, because this is just an old school analog kind of guy. And we're just going to follow the steps. We're going to check state of charge, which we've already done, but I imagine when we hook this up and the battery's not loaded yet, we should be able to see state of charge here. So okay to test, which we should know that we're in that range because we're going to be in the 12.5, 12.6 range. Apply load to battery equal to half the cold cranking amps. So 375, hold load for 15 seconds, read voltage, turn off load. I don't have a timer or anything because I use my I use my phone to do these. So we're just going to count out loud. Well, I guess I can look at the timer on the camera. We'll try that. Okay, let's kind of see what it's saying. Okay to test. We're barely in the range of okay to test. Let's go ahead and crank it up to 375 amps and we'll hold it for 15 seconds. And 1, 2, 3, 4, 5, 6. Oh, oh man. Well, we smoked it. Where did we go wrong? So reading through the manual, if tester has not been used for a period of time, moisture may have condensed between carbon pile discs. This will cause the tester to steam for a little during the first or second load application. This is normal and not a malfunction of the tester. Do not confuse this with heat due to overloading the tester. So it seems like it was probably just steam and not smoke, but I think we can go ahead and retest. I don't know what that beeping sound was. Let's try and get it up to that 375. See, I don't like that because now amps is not coming up and I just heard a popping sound in the device. And see, as we apply a load, no, this thing's definitely broken. It got cooked. All right, so we got a new unit here. I took back the old one and I got this one, and it's the same exact unit. It's just a different color and branded by a different company. So I don't know if I got a defective unit. Haven't touched the battery since. We'll want to make sure that it's off, and then we'll just do this super quick. Okay, won't go past there. I kind of want to charge the battery before I apply a load. It's hard to tell because of the parallax, but what I'm seeing is not okay to test. Let's try charging it first. And we'll retake all of our measurements and we'll do all of our testing all over again to start fresh. All right, let's see if we can't just get this test over with. Saying okay to test, saying that it's not. We're gonna just try it. Maybe we'll try it for a few less seconds. Doesn't like that. One, 2, 3, 4, 5, 6. Okay, we got smoke. The alarm went off. I heard a crack. I don't know if our tester's busted. We'll have to look at the footage at what the voltage dropped down to. We were supposed to do 15 seconds, but I think we got to maybe 7. It smells crispy. This knob feels really hard to turn. Let's put it all the way in the off position and just see what we can get out of it. Okay, it looks like it's still, no, it's sticking at 200. I think if we've taken anything away from this, it is that the carbon pile load testers are complete garbage and a huge waste of time and money. I'll be sending this one back. All right, I brought out the big guns. So obviously the last 2 units didn't work. I'm sure it's gonna say that this battery needs to be charged before testing, but we'll just put a load on it, maybe not even the full 375. Okay, so for this battery to pass, to get it to a good point, 9.6 volts, 9.6, 9.5, somewhere right around in there. This one is rated for 1,000 amps. So the idea here is, even though it's a very similar build, could be right out of the same factory, is that because it's twice the rating, it shouldn't be nearly as harsh of a load. And it also has 2 cooling fans that are built into the sides of it. Something that I also like is that it has options for 6, 12, and 24 volt battery. And it's gonna be the same testing procedures as the other ones. It's gonna be half the cold cranking amp rating for no more than 15 seconds. Look at the voltage. And then something that we want to pay attention to is we have different scales here. This is like an old analog meter. If we're reading a 6-volt battery, we would read the top scale. So 0, 1.5, 3, and so forth. For a 12 volt, we would read 0, 3, 6 to the 15. And then for our 24 volt batteries, 0, 6, 12, 18, right? And we're gonna see this needle chooch. These are much nicer clamps. Okay, I hear it kicking on. Okay, there's roughly where we want it to be. And okay, timed out. And I didn't see any voltage come on here. Man, that thing smells. Our voltmeter doesn't work at all. It's in the off position. Okay, you should be able to see there. We do have 12.4 volts. Our load tester should show a voltage, and there it is. Okay, so it's a little sticky on the needle. Let's try it one more time. And we're seeing that drop. Cool, that's all I want to do. We saw a drop below 8 volts. I don't know about those needles sticking, but better than the last 2. All right, I'll have to look back in the footage and see what we came up with, but it definitely dropped below 8 volts. I mean, it's like testing bad like crazy, and luckily our machine didn't blow up this time and given a tap on the old meter. I don't like that. I wonder if we can upgrade those to digital meters that won't stick. I've got it on repair mode on a smart battery charger. I'll have to look at the manual, but I think the repair mode will last like 12 hours or so. So I'll just let it do its thing over the next 2 days. And so the idea is to desulfate the battery with the repair mode. How well that works with a well-worn lead acid battery, I don't know. My hypothesis is that it will do nothing and we'll see no change in any of these results, and it will still test bad. I'll see you in 2 days. Welcome to the exciting conclusion. So we ran 2 24-hour repair cycles on our battery. So I haven't done any tests. Wow, we've actually seen some really impressive improvement. The milliohm rating is now at 4.77. That's insane. State of health is up to 67% with an estimated 616 cold cranking amps. Our voltage is super high though. It's at like 12.9. Let's bleed off a little bit of that excess voltage and let's retry that. 2, 3, 4, 5, 6. Okay, hit it 10 seconds with the bulb. Bled off about 1/10 of a volt. Okay, it's still being consistent as it can be. Let's write down these values. This makes me wonder if we should do another 48 hours. If we're seeing improvement, does that mean that we could keep going? You know what I mean? Like, this gives me hope. Let's see what the load tester says, because that's the true test. All right, let's just do it quick. I don't think we're gonna do the full 15 seconds. I think that we've learned that these machines can't handle it that long. Let's just try to hit our target amps and see what the voltage drops down to. And I think that should be sufficient to just test if there's been improvement, since that's what we did on our initial test. What's our voltage drop? Right there. Okay. I think this is testing, I don't think it's testing perfectly good, but I think it's testing significantly better. Okay, what of a roller coaster of emotions making this video has been. Between blowing up 2 carbon pile testers, the shocking results of the repair mode actually working. The way that I understood it was that the sulfation process is only occurring for a battery sitting for a long period of time and not being utilized and being undercharged. This battery has been in a daily driver. I mean, it's a worn battery. The repair mode shouldn't have done anything. So that tells me that there's a gap in my understanding and that I have way more to learn, which is really exciting. This brings up a lot of questions though. Just because we've seen some improvement in testing, you know, obviously we didn't do a full 15 seconds on the carbon pile load tester, but this also raises questions of, okay, well, how does it affect the capacitance of the battery? And how does it affect the longevity? Like, okay, it's testing good now, but in a few, you know, after a few load tests, is it going to test bad again? You know, is this a temporary repair? What are the long-term effects of this? So I don't have a way to test the capacitance right now. That's a piece of equipment that I've been waiting on that hopefully is in the mail. And it's another test that I wish I could have performed before we started this whole process. It's too late now. I think that we should do a part 2. I think we should do another like 48 or 72 hours on repair mode and bring it back and see if there's been even more improvement. Like, are we capped at the improvement that we got to? Like, did that improvement occur within a 24-hour repair cycle? So like something else that we could have added into our process is after every repair cycle, reran the series of tests. But I wasn't even thinking that because I just thought the whole thing, I thought it was a complete waste of time. I don't know, apparently it isn't, and maybe we can bring it back from the dead. I don't know, I've got hope now. I've got, like, you know, this video has been a trying process, and now I've got some wind back in my sails. So there it is. Let me know in the comments if we should do a part 2. So this is pretty exciting. And man, I'll catch you on the next one.